Yo, 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 year 10. Man, I messed up. I already recorded a video for you guys, and then there's this button here on my microphone which says mute. And at some point in the recording, I pressed it. So the first half of the video was fantastic, and then the second half, I was standing there talking and there was no noise there. So I'm re-recording this video. I'll make it super quick. This is a 2017 test. But it's not the whole test, because I know you guys today in class, you showed me you could do the basic level questions. So this is the harder ones only, B and A level. So the first one, these box and whisker plots represents the distance traveled to school by members of year 9 and 10. And what percentage of year 10 students traveled more than 9 kilometers? That's up there. And each little section here is 25% of the data. That's what you need to know. 25%. That's what finding these quartiles does. It shows you where the quarters are. Traveled less than 7 kilometers. There's your 7 all the way down to there. That's 1, 2, 3 quarters. So that's why it's 75%. And then for C, 216 year 10 students. How many between 5 and 9 kilometers? Between 5 and 9. 5 and 9. There we go. That's 50% because it's 2 of the quarters. 50% of 216 is 108. And that's why that was already up on the calculator, because I'd already done this. Now, that's all pretty straightforward, but this one D was getting harder. Hannah claims that the mean for the distance traveled by year 10 students is higher than the mean for year 9. So mean. We cannot tell the mean from box and whisker plot. We need the exact data for that. So what we can do is have a look at our data, and we can roughly guess which one would have a higher mean. So roughly guess, hey, yeah, the year 10 is probably going to have a higher mean, but can we say that for sure? No, because, as I drew up here, the year 10 data could all be clumped down the bottom end of each quarter, and the year 9 data could be clumped at the top end of each data. And if those clumps are real, those little red dots, then the year 9 mean would be higher than the year 10 mean. The year 9 mean could actually be higher than the year 10. So that's what I said here. I wrote down, it's possible that the year 9s have a higher mean, but only possible. Year 10 in data in each quarter could be low. Year 9 data in each quarter could be high. All right, next one. Batteries. 2 rival companies to see how many hours they've lost. And all it said was use the box and whisker plots to compare the performance. So straight away, you'd probably say charge up. Yeah, it's better. But to get a B, you need to go into some detail. So I did a 5-number summary, the lowest score Q1, median Q3, and the highest score. And you notice they've got the same lowest score. They've got the same median. But in the lower half, Me Strong has a quarter all the way down, is between 11 and 12. Whereas charge up, it's between 11 and 13. So that tells you that the bottom performing batteries are worse for Me Strong in that bottom quarter. When we look at the upper half, charge up is just way better. The third quarter there, instead of between 15 and 16, it's between 15 and 18. And the top performing batteries, Me Strong, 16 and 17, charge up, 18 and 21. So this is a clear-cut case. Charge up batteries are better. And I wrote down a lot there in order to get that B. You probably don't have to write that much to get a B, but you should write quite a bit in order to lock it in. But I'm going to scroll down in 3, 2, 1, down to the A one. This one was tricky. Like, I really have to think about this, like, for a lot. That's why it's an A-level question. So we've got a box and whisker plot and a histogram. And from the histogram, you can work out roughly where the median is, but you couldn't work it out exactly because of these ones were class centers. Class centers. So what that means is instead of saying, oh, the data was exactly 137 centimeters, 147, 152, those are groups. So for here, 137, what that means is actually it's the 135 to 140 range. They just took the middle, 137.5, and then for some reason rounded it down. They just left off the 0.5. It's a little bit unclear there. They should really provide more information. But because we have these class centers, you don't know exactly what the median is, what Q1 is, what Q3 is. You can't say that. but you can work out roughly. So there's 30 scores in total. The median is the average of the 15th and 16th, which was in here, this range, and then 160 to 165. And hey, that linked up. Yeah, the median's there at 160. Might not be accurate, but seems all right. Q1, it must be in that area. It's the 8th score, and that works out fine. And then Q3 must be in that area, is the 23rd score. And then it's got to be there, 165 to 130. So all good. Highest score, 178, 179. Yep, that's fine. It's in the right area. But there's only one thing that I found that didn't make sense, was here. This is like 134. But this range is 135 to 140. That can't match up. Those two things cannot match up. So that's why I said for the second question, could the information in the histogram represent the same 30 Year 10 students? No, because of that one. But it does say using 2 different points to support your answer. And for the life of me, all I can think of is the median being 160, and maybe it doesn't fall into that group. But oh well, maybe I wouldn't get an A on this question because I can't find the second reason why it's not the same. All right, I've spent long enough on this video because this is my second time through. So I'm going to stop here. Now, I know that was super quick, but yes, that's just an example of how to solve A and B level questions that are more than just calculating the basics. These are questions that made you think. All right, I'm recording this the day before the test, so hopefully you watch this, and good luck tomorrow.